Hey everyone, and welcome back to TechWithShas. Today we are diving into one of the most fundamental and powerful algorithms in machine learning, which is known as linear regression. Now you might hear regression and think it sounds complicated, but the idea is actually super simple. Have you ever wondered how can we predict stock prices? How do apps forecast the weather? How does a website estimate a house price from just a few details? Well, as you can see from all these examples on the screen, from the stock market, the real estate, the customer acquisition, and even disease spread, the answer often involves a form of linear regression. By the end of the video, you will understand exactly how it works. Let's get started. So, what is this concept altogether about linear regression, right? So, at its core, it's about finding a relationship between two variables. We have our y variable, which is called as a dependent variable. This is the thing we want to predict, like the house of a price. And we have our x variable, which is basically the independent variable. This is the thing we use to make our prediction. For example, the square foot price of a house. This formula you see here, right, sounds familiar or similar, right, from school days. It's basically the equation of a straight line. Here you can see the beta 1 is the slope. It tells you how much y changes for every unit change in x. For example, for every extra square feet in your house, how much price increases, right, in overall. The second beta, which is beta naught or beta 0, is the intercept. This is the baseline value of y when x is 0. This is a simple concept of line which we have studied in our school days. Look at the graph, right? All these blue dots are our data points. Like we have surveyed some data points, some price of houses, right? And then we plot it here. The goal of linear regression is to find the one best fit line, that red line which you see in the screen, that cuts through the data and best represents the relationship between x and y. So among all these data points which you see on the graph, the red line represents the best fit line, right? Now that leads to a great question, that how do we know that if our line is a good fit line or not? Because see, you can draw a bunch of different lines like these gray dashed ones here you can see. So now at this point, it is a metric called R squared. Okay. So you can think of R squared as a goodness of fit score from 0 to 1. It tells you what percentage of change in our y variable can be explained by our x variable. Here you can see on the top left hand corner that the value of R squared is 0.85. That's pretty good. It means 85% of the variation in our dependent variables, maybe our house price, can be explained by our independent variable, that is basically a square foot price, right? A high R square means a better fit. Those other lines would have a much lower R squared, which is how we know they are not the best lines, right? So by the value of R squared, you can find out the what is the best fit line. So I mean, computer cannot see, right, all these points on the graph. So how does it find the best fit line? Okay, so it doesn't guess, right? It uses mathematics. The main goal here, right, to minimize the error. The error is the distance from each blue data point to our red line. So the blue points are data which we have plotted on our graph, and then we find a distance from our red line, right? So to do this, we use something called as a loss function or cost function. I mean, both words are used interchangeably. A very common one is the MSE or mean squared error. Okay. So I mean, yeah, it might sound like very complicated. Okay, so don't let I mean, don't let it make you intimidate, right? So basically, the MSE, what it does, it measures the error for every single data point. Okay. Now, once you find all the error like actual and the predicted, and then you do the square those errors, right, to make them all positive because it might be negative and positive as well. So we square them. So that's why first we find the difference, then we do a square, and then we find the average. That's why it is called as a mean square error, right? So now here, right? So these graphs show the idea now the 3D ball, right? You can see on the left hand side and 2D curve on the right hand side, right? Which shows all possible error values. The algorithm, right? The linear regression algorithms job is what? Is to find the exact bottom of that bowl, right? Okay. So the point is of a minimum loss. So basically, what are we doing? We are trying to find our relationship a linear fashion so that the mean square value is the lowest. That gives us the best model or best fit line. Okay. And the parameters, basically the intercept and slope in this context, that gives us this minimum loss. And that's our best fit line. So in the previous slide, you have seen multiple lines were drawn. So what we do, we find out the MSE for all those lines, and whatever line has the lowest loss value or cost value, that represent the best fit line. Okay. Now, now I think we have built our model. So when we say we built a model, it means that we found out our linear regression line, basically a line, right? So we have the intercept, we have the slope, all those values we have got. So now that's fine. So whatever data we already have, we have got from the market survey or somewhere, right? Some source. So with that data, our model looks very perfect, very good. Okay. But how do we, because in the real world, right, data will be coming as a new data, right? So then in the new data, how do we know exactly it will work? Okay. So if data is new, how it's going to behave? So this is a crucial step in the machine learning, which is the train test method. Here you want to generalize our model. So our model has just seen data which we have fed into, but now we want to make sure that data which is like new to it, we're also able to predict with that as well in the perfect sense. So for this, what we do, we use the test train test split method. So what we do, we take our data set, which is originally we have got from source, whatever source we have, and we split it, right? The bigger chunk, mostly 80% or 70%, becomes our training data. So to train our model, we use that data so that we are able to find out the values of intercepts that beta 1 and beta 1, and then model learns from that data and we find out the optimal slope and the intercept, basically values of all those variables, parameters, right? Then the smaller chunk, which is 20 or 30%, is our testing data. So testing data is never shown to model, right? So the main concept here is that the test data should not be shown to the model and it should be hidden from it, right? Otherwise, if model already learned that data in the process of training, then you are not able to test it in a true sense. Okay. So may always make sure that test data is not exposed while training, and you do the proper test split. So finally, we use our train model to make predictions on this unseen test data and see how well it does. We evaluate it by calculating the mean square error and R squared on this test data. If the performance is good, we can be confident our model is useful, and then we can deploy it to production and measure the performance further as well. Okay, so this is the whole process of identifying the best fit line, testing it via the train test method, and then if we are good, deploy it to the production environment. Now, I think we have looked so far, whatever is basically the simple uh, linear regression with just one x variable, right? But in reality, life is more complex, right? So the price of house won't just depend upon the square, I mean the price per square feet, right? It also depends on number of bedrooms, the location of the house, age of the house, and many more parameters. Okay. So when you have multiple variables, this is where multiple linear regression comes into picture. The concept is almost the same, but now we use two or more independent variables like x1, x2, x3 predict our variable called y. Okay, as you can see in this formula, we are just not adding one slope, but we have like multiple slopes or multiple parameters here, right? So once we use the multiple layer regression, we can use multiple features of a product to make the best fit model. So let's bring back uh, to the real world our whole concept where we are using it actually, right? So basically, in business and economics, it's used for sales forecasting, predicting demand, and optimizing cost in various industries. In health and medicine, also it is used to analyze the drug dosage responses, like how much drug is going to basically suffice or for the for the patient, and the for the predict medical cost, or maybe predict the tumor growth, right? Also, it is used in social sciences to predict the academic performance of a population growth, right? Engineering as well. So there are various kind of a industries where they are used to test material strength versus temperature and few more, right? So basically, how do you know that which is the concept you are I mean the concept you are applying in some context, right? So whenever you see a set of input variables, right, and the continuous output you want to predict, okay? So that's a linear regression. It's a good start, a good place to start basically, right? Because if your relationship is linear, you definitely use the linear regression in your model. So, and that's it. So, and you now understand the core concept of uh, linear regression, and from the best fit line and the R squared loss function and the train test split. So, basically, these three concepts are very critical in linear regressions. If you understand what is the best fit line, how do we identify that, how R square is measured, and how and which R square is best for our model, and then how do we do the train test split for testing and the training of our model. Okay, so this concept is very easy in that case, right? So if you found this video useful and enjoyed this concept which I try to explain in very simple terms, please smash the like button. It really helps the channel because my channel is stuck, it's not growing at all. Be sure to subscribe to Tech with SAS and hit the bell icon so you don't miss out on my next video. Any questions if we have, or any other topic on machine learning, or architecture patterns, or design patterns, right? If you want me to cover, leave a comment down below. And thanks for watching, and I'll see you in the next one. Thank you very much.